All right, let's continue on with example number 2 in section 7.4. In example number 2b, it's asking us two different questions. The first one is asking us for f minus g of x. Or could I say f of x minus g of x means the same thing? We can figure out that one first, and then it's going to ask us the second question. The second question says, what is f minus g of negative 1? So a little bit different, right? The first one, we're still going to have x's in our answer, that variable there. And my second question, wherever we see an x in our answer, we've got to make sure that we then plug in negative 1 and still evaluate. All right, so f minus g of x is really f of x minus g of x. So what is f of x? Well, f of x is the x squared minus x, right? So I can plug that in. Minus g of x. Well, g of x is the x plus 2, so I can plug that in. Now be careful, you notice that I put it in parentheses? That's really important, especially if we're subtracting, because I need to make sure that I distribute that negative, because I want to subtract all the terms in g, not just the first one. So making sure you distribute the negative, then we can combine like terms and say that f minus g of x is really x squared minus 2x minus 2. Now that we've figured out what f minus g is, can we do f minus g of negative 1? And now take our answer that we just got when we subtracted them and kept the x's, but this time plug in a negative 1 wherever we see an x. So now I can take my answer, wherever I see an x I can plug in a negative 1, and then I can simplify to figure out what f minus g of negative 1 is. Negative 1 squared is 1, negative 2 times negative 1 is positive 2, and then I have a minus 2 in the back. So I end up getting a final answer of positive 1. So f minus g of x, we have variables in the answer. F minus g of negative 1 ends up with just a number as my answer. Okay? All right, let's do a practice of division and multiplication of two different functions. Same kind of rules. On C, if I want to do f divided by g of x, my answer is just going to have x's in them. But if I want you to do f divided by g of negative 3, then as soon as I'm done dividing, I've got to make sure that I plug in a negative 3. All right, f of x divided by g of x, we could do them separately. So we know that f of x was my x squared minus x, my g of x was my x plus 2. And now the only thing that I'm worried about now, because I have a rational expression, is that denominator. So x can be anything except for what's going to cause that denominator to equal 0. So I can say that f divided by g of x is x squared minus x over x plus 2, as long as x does not equal negative 2. All right, let's continue and do the second part of that problem where it asks us to do f divided by g of negative 3. So we already divided the two functions up above. Now let's just evaluate by plugging in our negative 3. So when I plug in my negative 3, I end up getting 9 plus 3 in my numerator and negative 1 in my denominator, which ended up giving me negative 12 for my final answer. And as long as x wasn't negative 2, I should have gotten a valid solution there. All right, look at D, multiplication. F times g of 4. So I know that my answer is going to be just a constant, just a number. I'm going to take f, I'm going to multiply it by g, and I'm going to plug in a 4. Or you could do f of 4, do g of 4, and then multiply them together. You should get the same final answer either way. Try it both ways just to double check. What is f of 4 though? Well, if I plug in 4 for f, I ended up getting 12. If you plug in 4 for g, you end up getting 6. Then I can multiply them together, 12 times 6, and say that f times g of 4 is 72. Or I could have multiplied f times g first, FOILed it, combined like terms, and then plugged in a 4. You should still get 72 for your final answer. Try it.